Okay, this video goes over the homework solutions, the problems 1 through 8, or 1 and 8 from chapter 9, and problems 1, 4, 6, and 24 of chapter 10. Problem 9, they wanted you to build a Pareto chart. They gave you a list of things that were done. I used a pivot table to quickly generate the check sheet, so when I generate the data, I brought the work over to the rows and then brought the work over to the values, which it counts it. I sorted it. I sorted it from high to low or large to small, and then I built a graph of it. So what happens most often are lube and oil and brakes. Transmissions don't happen very often. Problem 8 out of chapter 9, they wanted you to do the scatter plots. You plotted the age and temperature on the horizontal axis. Those are the things that we think we can control, and the result is some type of, in this case, an absentee rate or an error rate. You can see it's pretty linear. It looks like the absentee rate drops down the older you get. On the temperature error rate, you can see that we've kind of got a spot. It's a non-linear type effect. When we deviate much from around 70 or so, our errors increase. So when it gets really cold, our errors increase. When it gets really warm, our errors increase. Chapter 10, I'm not grading this one. This one, if you get this right, it's extra credit. They give you the lower spec, the upper spec. So these are the customer requirements. These are our inputs. And then this is the data. We have a process that's centered at 24.5 with the standard deviation of 0.2. They want you to calculate the percentage that are below this number or above this number. To use that, we use the norm dist to find the area below the lower spec, and then to find the area above the upper spec, you use 1 minus norm dist. The norm dist always gives you the cumulative area, which is the area to the left of some value. So if you need the area to the right, you got to subtract that from 1. You add those up, and I show it in a percentage form. The second part of the question is they want you to calculate control limits, or calculate the two values that 95.44% of the time you'll get points. The average will be between, a sample average will be between what two values. So they give us this, and the first thing I do is calculate how many standard deviations that band is. And if you look how you calculate it, you take that 0.9544, which is the middle, and then I take half of the that distance, 1 minus that value, then cut that in half, and that will give you your plus or minus how many standard deviations, which it turns out to be 2. If this was 99.7, if this was 0.9973, you get plus or minus 3. Plus or minus 2 is 0.9544. 0.68 is 1. That's some things you can memorize. Because we're plotting averages, they give us a sample size, and when the sample size, so to calculate the standard error, you take your standard deviation divided by the square root of the sample size. That's from stats. Standard error is the process standard deviation divided by the sample size. So now that we've got this number, what I'm going to do is take this number plus or minus this many standard deviations multiplied by the standard error. So this plus or minus this times this will give me these two values. And this number is the plus or minus standard deviations multiplied by the standard error. So this plus this and this minus this gives us these two numbers. So for a system in control, the average will be between these two values 95.44% of the time. 10.4, they want you to build control limits for a process that has continuous numbers. It was a little bit tricky. What they gave you were 6 samples, and there were 5 observations per sample. And you could lay the data out any way you want, but this is probably the better way to do it, because as you go into the future, you'll always get more samples, but every time you take a sample, you'll get 5 observations. These are my constants. Observations per sample is 5. So from my quality control table of constants, these are my A2, D3, and D4. For each of these samples, I can calculate a sample average and a sample range. Then this is my overall average. This is my average of my ranges. These are my control limits then for my X bar and my R's. And that's what these are. And then this graph is a plot. This is a plot of the control limits in X bar. This is the plot of your range control limits in R. And since they're within the control limits, we say our process is in control. Problem 10, they gave us the count of retest out of an area of opportunity. So for each sample, I can calculate a sample proportion. The sample proportion is what we're going to plot in our P-chart. That's what this is a P-chart. To calculate the control limits, we need to be able to calculate the average. We need the center line, which is the average of my proportions. The standard deviation of P, a sigma of P, is the square root of P bar times 1 minus P bar divided by the area of opportunity, which is 200. And they wanted us to do plus or minus 2 standard deviations. If you did 3, that's fine. That's typically what's done, but they wanted you to do 2. I use 2, and I calculate then the center line plus 2 sigmas. The lower, I always lower bound it at 0, so it won't be negative. You can't get a negative proportion. So I took this minus 2 of these, but if that's negative, I lower bound it at 0 by using this function, or nesting the function with the max, using the max function. So once I have these two values, I can plot those in P, and you get this. And we are out of control in sample 10. So sample 10, you probably go investigate what happened at that time because you went out of control. Problem 1024, I'm not grading. I want you to calculate defects per million opportunity, which again, you're using the norm disk function to calculate areas to the lower, less than the lower spec, and 1 minus norm disk multiplied by the area to the right of the upper spec, given the mean and the standard deviation. You can add those up, and to calculate DPMO, you take this number, multiply by 1,000,000 to get these. The starting point of goodness is about 2,700, so these are pretty good. That's really good. That's probably needs not the greatest. Okay, so that's the homework.